Last time, we were going to find the volume of pyramids and cones. So we did pyramids, and today we will take a gander at cones. So the volume of a cone, by the way, is exactly the same as the volume of a pyramid. So remember that the volume of a pyramid is 1/3 times the area of your base times the height. However, remember that a cone has the base that is a circle. So that means B is just pi r squared every single time. So when I substitute in, I get 1/3 pi r squared times h. Previously, when we looked at cones, we looked at surface area of cones. And the surface area of the cone was something like this: pi r squared plus pi r L. So remember that L was important. All right, so let's go ahead and attack. We'll look at a couple types of problems, one of them where we know the volume and one of them where we don't know the volume. So pi r squared h is what we're going to use. And all we have to do is identify here. Of course, that's my radius. And this is the height of my cylinder. So I plug these in. So 1/3 times pi times 4 squared times my height, 6 inches. So continuing to simplify here, I can even reduce the 1/3 right now. So 1/3 of 6 is 2. So when I simplify this, I get 32 pi. And when I multiply, to get approximately 100.5 cubic inches. And both of these are acceptable answers depending on the instructions. Again, this is in terms of pi, and this would be an approximate rounded to the nearest tenth. All right, notice that the other problems, 3, 4, and 5, all have given to us the necessary components. We already have our radius, we already have our height. Notice that this is an oblique, meaning it's slightly leaning. However, the formula still applies. This is still the height from the top, or from the base down here, perpendicular to the base, all the way up to the vertex there. So that's still my height. It's not a lateral height, or a slant height. It's the actual height. So we're going to use the same formula there. Let's look at, though, number 6. Number 6. We are not given h, we are given L. So, and of course we have the radius. So before I can actually plug and play on these ones, I should go ahead and, if need be, resketch and find out my height. So I need to find out the height here. So I know that this green is 6, that represents the radius. I know my hypotenuse of the triangle if I take this cross section inside the triangle, inside the cone. So that's a 10 there. So when we set up Pythagorean theorem, recall that it has to be 10 squared is the one that is by itself. That's the hypotenuse. Again, c squared can be on either side as long as it's alone. Now, when I subtract, I get 64 equals h, and h, squared, and h is exactly 8. So now we have the height. So I used Pythagorean theorem to find the height. Many of you could have recognized that this was actually a Pythagorean triple, and you didn't have to show any work. So volume is equal to 1/3 pi r squared h. Now we just plug and play. Oops, that's a 1/3, not a 1/2. My radius is 6. And now my height is 8. Notice I would not reduce the 1/3 now. earlier, I reduced this 1/3 and the 6, that was a height outside there. But don't reduce inside here because the order of operation says the multiplication has to happen first. So this would look like this. Just multiply all that out to get 36 times 8 divided by 3. 96 pi, and that is approximately 301.6 cubic